Welcome back as we next look at the methods used to create bends in metal conduit. Unlike PVC, which can literally be bent by hand, metal conduit has to be bent using a specially constructed tool known simply as a conduit bender. The two main sections are the handle and the head. The head consists of the hooked lip, the slot, the grooved head, which creates the bend, and the heel. Bending of metal conduit is an acquired skill that comes with much practice. A few tips will help you to master this skill. The traditional method of bending is to place the work onto the ground. A rubber mat will help prevent the work from slipping around. Pressure is maintained with your foot upon the heel. The handle is pulled steadily but firmly. Conduit is tough, so you will require considerable force to pull the handle. Where it is not possible to place the work on the ground, the bender can be used in an inverted position. The important factor here is to make sure that the bender is well supported and that you keep your hands well away from the bending lip. You will notice that your feet play an important role in the support and balance of all bending operations. Benders are made for different sizes of conduit. We are using the bender designed to accommodate 20 mm conduit. Before you use any bender, it is recommended that you test it to determine its bending dimensions. One method is as follows. Obtain a straight offcut of conduit and lay it upon a flat section of the floor. With chalk or a marker pen, draw a line along one edge so that the mark transfers onto the conduit. This will be a reference edge to indicate the top when you place it into the bender. Now measure back and make a reference mark approximately 100 mm from the end. Place the conduit into the bender as shown and position the mark to the lip. To create a 45-degree set or angle, the conduit is bent until the heel is roughly parallel to the ground. A 45-degree tri-square can be used to check the angle. You may have to bend a little more until the angle is correct. Next, a mark is made at the center of the bend. From this mark, we measure the distance to the reference mark. In this example, the distance is 75 mm. This figure is noted and kept for later reference as the 45-degree bending point. Now we'll create a 90-degree bend. This is made by trial and check. Note that it is important not to overbend, as it is very difficult to bend back. Rather make small, progressive bends until you achieve 90 degrees according to a square. A measurement is now taken from the level ground up to the original reference mark. In this case, the figure is 130 mm. This is recorded as the 90-degree bending point. We now have the references of this particular bender in order to maintain accuracy when bending to a profile. Let's see how to make an accurate bend using this information. As an example, let us create a section where a 90-degree bend must be made exactly 500 mm from one end. We begin by placing some tape onto one end of the conduit. This will be our reference end for measuring and bending, as you will see. The conduit is placed over the profile with the reference end on the end of the 500 mm leg. The corner position is then marked. From this mark, we measure back, toward the taped reference edge, 130 millimeters, which is the figure for a 90-degree bend with our bender. Place the conduit into the bender. Note where the referenced or taped end is. Slip the conduit in until the 130 mark aligns to the lip. The bend is now made to 90 degrees. This you will want to check using a square. When we check our conduit upon the profile, you will see that it is right on the line. The bending of metal conduit, as earlier mentioned, is a skill that can only be acquired through practice. What did we learn in this section of this program? We learnt that metal conduit must be bent using a special conduit bender. Benders are available according to the various standard size or diameter of conduit. We learnt that the use of a rubber mat will help to prevent the work from slipping. When bending, we must keep our body weight upon the bender and pull on the handle steadily. We then learnt that each bender can be checked as to its bending dimensions and that we can produce accurate bends to a given profile using this information. After the break, we shall look at making a typical bend.